Okey, Assalamualaikum dan selamat pagi. Alright, kita mulakan kelas dengan doa masing-masing. Bagi agama Islam, kita mulakan kelas dengan Ummul Kitab Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Arrahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okey, saya beri masa dalam 2 minit untuk scan attendance sekejap. Sebab saya dah bagi masa lama untuk you all masuk ni. Mungkin ada yang ingat kelas asynchronous. Tapi kita dah mention yang kelas kita dibuat juga synchronous untuk bincang kuis lepas. Sebab ada yang request dengan saya untuk dapatkan skema kuis. Tapi setelah saya bincang dengan saya punya ni lah ketua panel sebagainya, sebenarnya kami tak boleh berikan skema, apa-apa skema kuis, test, exam sebagainya kerana itu adalah confidential. Alright. So I cannot give it to you. So saya share sekejap attendance, you all scan sekejap. Please 1 minute lagi. Ada antara you all yang tak boleh attend, saya tahulah siapa kan yang ada mak dia sakit dan sebagainya. Okey, saya tak ada masalah, saya dah take note. Tapi seorang je. Right, done? Hurry up. Scan attendance sekejap. 30 saat lagi sebab saya bagi. Okey. So kita akan discuss kedua-dua quiz kita yang dah dibuat sebelum ni. Okey, quiz 1 dan juga quiz 2. Okey, sorry saya punya words tak respon. Kita ulang kaji quiz 1 dan quiz 2 ni sebab test minggu depan, okey, kebanyakan topik yang sama kan masuk. Itu daripada awal chapter sampailah ke SPME. I don't know what happened to my words. Okay. Now, okay, kita tengok quiz 1 yang kita dah buat. Bila tarikhnya quiz 1 ni? Siapa ingat? Quiz 1 tarikh bila? Bila quiz 1? Siapa ingat? Saya kalau tak ada respon saya anggap you all tidur ni dalam kelas ni. Right? Nasib baik Michelle semua bagi tahu Okay. 7 April. Please respon Kelas saya tak suka tau cakap seorang-seorang ni. Okay. Make it as usual lah. You all kan respon saya punya kelas kan. Dengan Dr. Afiq nanti pun please respon Alright. Tengok soalan pertama. Indicate forces involved in the separation method. Okay, ada dua markah. You all tengok ada dua markah ni meaning that minimum you all kena letak dua. Kalau letak lebih, okay, mana tahu satu salah, dua betul, so you dapat dua markah. Right? Tips nak jawab quiz, nak jawab test, you tengok markah tu betul-betul. Kalau markah tu 5, then maybe maknanya bukan maybe, something that contribute to 5 marks. Tapi ini ada 2 markah, so that you kena bagi 2 lah. At least, okay. Any of 2 below lah, okay. Force involved in separation itu mechanical, physical means or chemical reactions. Alright. And then soalan kedua, okay, assign 2 advanced novel methods that are suitable for the separation of compound mixture. Okay, sama juga 2 markah. Okay, this is you tengok level dia CLO1 CLO1 level knowledge, okay. Level knowledge yang basic tu. So I tanya direct, tak ada application apa-apa. Okay. 2 advanced novel methods suitable for the separation of compound mixture. Advanced lah bukan yang method biasa. So magnetic separation, electrically driven separations, moving membrane system, liquid membranes, chromatography, and also lab on chip. Any 2 of these answers, so you get 2 marks. Right? Faham Okay, this is soalan ketiga bukan keempat. Right, soalan ketiga. Okay. Compare the difference between, okay, differences lah, okay. Difference between partition coefficient KP and distribution coefficient KD. Tengok markah dia ada 4. Right? Meaning that kalau you bagi 1 jadi different, you all dapat 2 markah lah. Itu you all bagi what is KP rather than KD, you all dapat 2 markah. Tapi you kena bagi 2 difference. Alright? So dapat 4 markah. Ratio yang pertama ialah ratio of concentration of an ionized compound between the 2 phases. 1 mark. Okay, for KP. Right? And then yang kedua ialah pH of the aqueous phase is adjusted such that the predominant form of the compound is unionized. So you all dapat satu lagi markah. Okay. So untuk KD, okay, ada 3 tapi saya tulis kat situ. Any of 2 below you can get 2 marks lah. Okay. 1 dapat 1 mark. Okay. The first one for KD is ratio of concentration, okay, of ionized and ionized compound in the 2 phases of a mixture of 2 immiscible liquid at equilibrium. That is KD. Second one, a measure of differential solubility of the compound between these 2 solvents. Okay, a measure of differential solubility of the compound between these 2 solvents. And the third one is distribution coefficient are useful, for example, in estimating distribution of drugs within the body. This is for the application. Okay. You bagi either 2 of this, you dapat 2 markah. So KP 2 markah, KD 2 markah, you all dapat total 4 markah. Okay. Alright. And then soalan keempat. Okay. At point Z, a mixture of compound X and Y is in the water phase. Okay. Point Z, X and Y is in the water phase, meaning that number of phase is 1. Analyze the number of variables in the form of degree of freedom that is required to define the point Z. Okay. So this is CLO2 because it's quite application question. Okay. So you all dapat 3 markah. Okay. So masukkan yang pertama equation. G equal to C minus B plus 2. You all dapat 1 mark. And then you all define what is C, okay, number of components, B, number of phases, and then plus 2, you all dapat 1 more mark. So, in this case, number of component ada berapa? 2 kan? X and Y. And then, number of phases ada 1. Water phase. Right? And then you all dapat 2 minus 1 plus 2. Okay, you all dapat berapa? You all dapat 3 kan? So, 3 variables. Okay, salah je. Okay, 3 variables require to define point Z. You all dapat 1 mark. So total 3 marks. Alright. The last question. Okay. The Raoult's law. Okay. Ini pun sebenarnya direct question je. Cuma dia ada application lah. I bagi kan. According to Raoult's law, the partial vapor pressure of each component of an ideal mixture of liquids is equal to the vapor pressure of the pure component multiplied by its mole fraction in the mixture. So I bagi definition of Raoult's law. So ada rho A equal to XA times rho A naught. Okay. Apa itu rho A? Apa itu rho A? The partial pressure lah. Okay. Partial pressure of component. Okay. Component A dalam mixture of A and something else. And then what is XA? The number of mole of component A. And rho A naught. Apa rho A naught? Okay. The mole fraction kan? Okay, SA. Rho A naught apa rho A naught? What is rho A naught? Rho A naught is not partial pressure. It's the original vapor pressure dia lah. Okay. Rho A naught is original vapor pressure dia of component A. Suppose we contain 100 ml of water and 100 ml of ethylene glycol in two different containers. Okay. If the vapor pressure of pure water is 500 millimeter mercury, identify the new vapor pressure of the water that is made by mixing these two substances together. Right? Dia bagi, dalam soalan ni diberi ialah volume dan juga original pressure of water kan? Dan soalan dia ialah identify the new vapor pressure of the water. So that dalam this equation kena ada apa? Rho ni apa? Rho ni apa rho ni? Okay, vapor pressure kan? Right? Tapi dalam equation ni yang include adalah mole kan? So dalam dalam question ni I letak ada molecular weight. Okay? Ada juga tengok maklumat dalam ni penting. Kita tengok dalam maklumat ni apa diberikan supaya kita tahu apa kita nak kira nanti. So kita dapat dalam question ni ialah molecular weight of water and also ethylene glycol and then density. Okay? Kita ada density, right? Kita ada dua maklumat ini. Okay? Kalau kita diberikan, okay, kalau dalam equation ni yang kita nak ialah mole kan, mole fraction dia kan, okay, number of mole dia kan. Tapi maklumat yang kita ada ialah molecular weight. So kita nak dapat mole kita kena darab dengan dia punya apa? Dia punya berat. Okay. Dia punya berat pula. Dia punya volume. Betul ke? Tak adalah. Dia punya berat lah. Okay. Kita ada molecular weight. Dan juga kita ada maklumatnya apa? Okay. Kita nak dapatkan mole. Kita ada molecular weight. Kita nak darab dengan berat dia lah. So berat kita tak ada. Kita ada apa? Volume. So apa lagi maklumat yang diberikan? Kita ada density. So daripada density kita boleh tahu berat dia. Okay. So mole of water, okay, gram of water, darablah dulu dengan density. Volume darab density, dapatlah berapa gram. Mole of water, darab pula molecular weight, darab dengan, okay, berat itu, berat yang kita dapat tadi bahagi dengan molecular weight, dapatlah berapa mole kan. Right? Okay, and then dekat situ dia dapat satu markah dah. Berapa mol water you dapat? Dapat 1 markah. And then you kira pula mol of ethylene glycol. Okay, dapat pula berapa mol? Dapat lagi 1 markah. Right, then masukkan dalam equation. Okay, masukkan dalam equation. So berapa apa nama ni partial pressure bagi water? Okay, you all kena cari fraction mol dia kan. Berapa mol fraction dia? So 5.56 bahagi dengan 5.56 tambah 1.85 kan? Berapa fraction dalam tu? Total dia 5.56 tambah 1.85 kan, mol dia tu. Fraction dia ambil yang air 5.56 bahagilah dengan total. So dapat fraction, darab dengan original pressure, dapatlah the partial pressure. Okay, itu sahaja. Okay, soalan memanglah kepusing sikit, takkanlah nak bagi direct kan. So bagilah volume dan kita bagi density, you all kira dapatlah. Okay, so understood itulah cara kiranya, Raoult's law. Alright, from quiz 1, ada question nak tanya? Ada soalan? This discussion also recorded. Saya akan upload dalam e-learning as usual lah. No question. Okay, easy kan? Quiz. This one is direct except for this soalan nombor 5 lah. Okay. Nombor 4 pun quite easy. Okay. Nombor 5 ni just pusing sikit je lah. Alright. So, tak ada soalan. Kalau ada, buka mic ataupun chat. Okay, kalau tak ada, saya stop sharing. Kita pergi kepada quiz 2. Okay, so quiz 2. Alright. Bila tarikh quiz 2? Oh, laju. Okay. 21 April. Okay. Alright, so the first question. Also the knowledge level of question, CLO1, PLO1. State the difference between packing and tray in the distillation methods. Okay, packing and trays. What is the difference? Right? Direct question. Okay, if you read the notes, you can answer it. Okay, for packing, extra interfacial area for liquid vapor contact. For tray, lower interfacial area for liquid vapor contact. Okay, for packing, more efficiency in separation for certain column length. For trays, less efficiency in separation for certain column length. For packing, pack column are shorter and for tray are longer. Right? So you give any two below. Okay, any two comparison. Okay, two difference. So you get 2 marks. Right. The second question, based on the assumption of constant molar overflow, McCubbell-Thiele method requires some situation. List down the situation. Right? The molar heats of vaporization of the feed components are equal. Okay, any of these two. Okay. For every mole of liquid vaporized, a mole of vapor is condensed. Right? Meaning that this assumption of constant molar overflow is important to McCubbell-Thiele method. Alright, this situation of assumption is very important. Contohnya, yang pertama, molar heat of vaporization of the feed component are equal. Okay, every mole liquid vaporized, a mole of vapor is condensed. Okay, nothing loose within the process. Okay, and then the third one, heat effects such as heats of solution and heat transfer to and from the distillation column are negligible. Okay, heat effects such as heat of solution and heat transfer to and from the distillation column are negligible. Right, this is assumption for the constant molar overflow required for the McCubbell-Thiele method. Alright, any of these two. Okay, and then the third question, 1.5 liter of organic compound solution. Okay, what type of process is this? Liquid extraction, kan? 1.5 liter of organic compound solution containing 8 gram of benzoic acid. Okay. Okay, this is our, so benzoic acid is our analyte. Okay, in the organic layer. So this is twist, kan? Biasa kita extract from aqueous layer guna organic solvent. This is twist. So methyl tertiary butyl ether, okay, MTBE solvent was used to extract the benzoic acid from the organic compounds into the diluted sodium bicarbonate solution via liquid extraction. Okay. The extracted benzoic acid was transformed into sodium benzoate aqueous solution after LLE. Calculate the total amount of the analyte extracted if the LLE process performed within 1:4 ratio for 3 times. This is quite tricky lah. Okay. Assuming the extraction process obey the distribution coefficient at equilibrium, meaning that it occur at normal equilibrium. Okay, they obey the distribution coefficient. Okay. Apa maksud obey the distribution coefficient? Meaning that for every apa nama ni, the ratio is equal lah. Meaning that if kita guna 1:1 ratio, so that the analyte will divide by 2, kan? Fraction of the analyte will divide by 2 lah. Okay, 1 in the apa nama ni, original phase, ni lah phase ataupun original solution. The other 1 ratio of the analyte in the apa nama, extracted in the another solution. Okay, or another apa nama ni, layer yang ada dalam LLE. Alright, so sekarang ni kita tak guna 1:1 ratio. Okay, contohnya sekarang kita ada 1.5 liter, kan? Tak, kita ada okay, 1.5 liter of organic compound, kan? Kalau 1:1 ratio, kita masukkan how many of the apa nama ni, kita extract guna apa? Okay, metal terceri buta iter MTB solvent was used to extract the bond. Okay. MTBE kita berapa banyak? Tak, maksud saya, alright, sekarang ni kita masukkan MTBE, alright. Right, sekarang ni kita masuk MTBE dalam apa nama ni, organic compound yang ada. No, you tak faham. Okay, katakan saya tak guna 1:4 ratio. Memang tak mention total volume MTBE. Memang tak mention. Okay. Katakan sekarang you just yes, betul. Okay, 1.5 liter lah. Kalau saya guna 1.1 ratio nak extract from this organic compound. Okay, extractant saya tu solvent saya yang guna untuk extract the compound berapa banyak? 1.5 lah, equal volume. Sekarang ni saya guna 1:4 ratio. Okay, maknanya that 1.5 tu, okay, apa nama ni, 1.5 liter of the organic solution yang kita nak extract di extractant tu, right, kalau saya guna 1:4 ratio, meaning that saya masuk 4 kali, 4 step kan. So 1.5 divide by 4 lah. Tapi tak perlu, the volume tak penting kat sini. Asalkan, sebab soalan saya ialah total amount of analyte. Okay. Kalau 1:4, you all faham lah. That meaning that divide by 4. Okay. Faham tak? For example, if 100%, so it should be the solvent that used to extract this analyte, okay, the compound from the original sample, okay, from original solvent, original solution tu, sample tu ialah 25% by each lah. Saya masukkan di solvent to extract, okay. So the first portion, okay, the first portion, okay, for using 1:4 ratio, okay, is 0.2. Sebab sekarang kita guna 4 portion kan? 4 portion, right? Why not divide by 5? Apa? Yes, by 5. Sebab 1:4, okay. Bila 1:4 ratio, okay, 4 plus 1 is 5, okay. No, bukan 1/5. Okay. You all kena faham. Okay. Kalau ratio dia berbeza dengan pecahan tau. Okay. You kena back to basic balik. Sekarang ni 1:4 ratio, meaning that, okay, that analyte, okay, the original portion is 5. Okay. Sorry, abaikan persen tadi, okay. Original portion is 5. 4 plus 1 is 5. Okay. So, if you divide by 1:4, kita guna 1:4 ratio, meaning that, okay, kita akan ada 4 kali extraction. Okay, kita akan ada 4 kali proses tu. Kita divide by 4 solvent. Tetapi analyte itu yang masuk dia terbahagi kepada 5 sebab 4 kali solvent, okay, dan 4 portion solvent, 1 portion ada dalam original solution. Okay, sebab tu saya cakap dia obey distribution coefficient. Okay, you jangan confuse dengan pecahan tau. You jangan confuse dengan pecahan. Alright, you back to notes balik. Sebab tu kalau saya guna 2 kali extraction, okay, 1:2 ratio. Okay, the first, kalau saya guna direct, katakan saya ada sekarang ni 8 gram, saya guna 1:2, saya guna 1:1 ratio. Okay, sekali saya extract, saya akan dapat 4 gram. Okay, sekali saya extract, saya akan dapat 4 gram. So, kalau saya guna 1.5 liter, okay, 1.5 liter solvent. Sekarang ni 1.5 liter solvent tu kita divide by 4. Okay. So, nak tunjukkan bahawa 4 kali, bila kita pecahkan 4 kali, it is better. Alright. Kita akan dapat lebih daripada 4 gram analyte. Tapi kenapa dekat sini ada 3.9? Itu saya cakap dalam soalan tu, 3 kali berapa you dapat? Okay. Dan kalau you tambah lagi sekali, you akan dapat lebih daripada 4 gram. Betul tak? So, better than you guna 1-to-1 ratio. You divide the solvent for extraction by 4. Okay. And then you dapat lebih daripada you guna LLE 1-to-1 ratio. This is the objective. Alright. So, you have class. So, this question you faham right? So, you calculate for every portion. Okay, you akan dapat berapa kan? 0.2 darab 8, you dapat 1.6. Okay. So, second one 0.2. So, analyte dalam tu dah berkurang banyak 1.6. You ambil lagi, you extract lagi the second portion, you dapat 0.2 plus the remaining, times the remaining 6.4, you dapat 1.28. So, dalam analyte dalam solution dah berkurang. So, jadi 5.12 kan. You extract lagi, you dapat 1.024. Right, then you extract lagi, ada lagi bilangan jumlah analyte yang you dapat. Tapi saya dalam question saya nak 3 kali je, you dapat berapa? So that you tambahlah setakat 3 kali extraction tu. So you dapat 3.904. Ramai yang betul saya tengok Ini ada yang faham lah. Okay. So soalan seterusnya. Soalan nombor 4. Ini nombor 4 sorry. 4. A kind of triglyceride called trimethyltrypsin was extracted using nutmeg. Okay, ni yang dalam contoh video saya bagi dulu lah. From nutmeg using conventional method. This process is considered costly. Suggest this method. And what are these advantages of this method? Of course lah, chocolate extraction. Dan you senaraikanlah disadvantages of the chocolate. Kan, use a lot of solvent, waste disposal, extra cost, pre-concentration step needed, and what so on. So, you bagi tahu chocolate dapat 1. You give any 2 of this, you dapat lagi 2 markah. Right? Contoh you bagi use a large amount of solvent, dapat 1. Require large amount of sample, dapat 1. So, you dapat full mark already. Alright, and then the last question. A soil sample which was contaminated with an organic waste, was taken from a riverbank. Suggests a method that does not require any solvent and use a minimal amount of sample to analyze the possible pollutant inside the soil. Explain the advantages of this method. Right? Then you namakan this method sama macam atas tadi. So what is this? SPME lah. Okay, does not require any solvent and then require a small amount of sample. Of course, SPME. Alright, and then disadvantages, you letaklah 3 of these. Okay, advantages. So dapat 3 markah dan dapat tambah you punya jawapan what kind of method is it. So dapat 4 markah total. Okay, a simple effective adsorption technique. Eliminate the need for solvent or complicated apparatus. Right, compatible with analyte separation. GC-HPLC, reduce interfering background. So you dapat total marks. Okay, that's all. Saya akan upload nanti video of this discussion inside the e-learning. Okay, okay, you all ada kelas, tak apa. Okay, itu sahaja untuk kita punya revision for the quiz. Okay, jumpa lagi lain kali. Okay, be ready for the test next week. Assalamualaikum and thank you so much. Alright, most welcome. Nazira, most welcome. Okay, Boon, welcome. Shaza, welcome. Okay, Pevi, Huiling, okay, welcome. Okay, welcome. Lim, Siti Nurhaliza. Oh, I thought Siti Nurhaliza tadi. Siti Nurhaliza. Is Hazid Najiha, Sharfa, Tan. Okay, welcome. Hang. Alright, see you again. Bye-bye.